All right, I think it's time. Welcome back. Hope you've had a chance to check out the homework. Check it out. Um, Today, I would like to talk about curve sketching. It turns out that all the stuff we were doing last time about increasing versus decreasing and also concave up versus concave down, all of that stuff can be turned into a general purpose method for drawing the graph of any function. Now, we're going to use our calculators every so often, but for the most part, you can do this totally by hand as long as your function is nice enough so that you can take the derivatives. So that's what I mean by curve sketching. Draw the graph. So using the increasing and decreasing intervals and also the concave up and down stuff. Concave up versus down. We can draw the graph. Or at least sort of a representative sketch of the general shape of the graph. All right? This shouldn't sound too crazy. I mean, if you know like when it's going up and when it's going down, increasing and decreasing, that basically is describing the shape of the graph. So we're just going to try and do this in some amount of detail this time. I don't think it's worth describing a big procedure for it. I just want to do some examples. Come on now. Examples. All right. How about, let's start with a fairly easier type one. F of x equals x to the 4 minus 4x cubed. All right? Your job is to draw the graph, obviously without using your graphing calculator. Although, in a few of these, we're going to use a calculator just to like calculate values of points so that I don't have to work them out by hand, but we are not going to use the graphing calculator, the graphing part of your calculator. All right, draw the graph. So my strategy is, first of all, I'm going to find the intervals of increasing and decreasing, and also concave up and concave down. And this is what we did last time. So it's, if you remember how to do it, it's fairly routine, right? For increasing, decreasing, we find the critical numbers, which is where the derivative is 0 or does not exist. We choose like test points in between those values and then plug in and see if it's positive or negative. We did this last time. If you don't remember, you're about to be refreshed. So first of all, the increasing, decreasing thing, right? I begin by finding the critical numbers, which involves the derivative. So f prime of x is 4x cubed minus 12x squared, right? That's the derivative of this thing. The critical numbers are where the derivative is 0 or where the derivative does not exist. Now, everything exists in this case because I don't have any denominators or any other funny business. So really, I only care about f prime equaling 0. But before I get to that, let's simplify as much as we can. I think here we can factor out 4x squared from both of those, right? And then what remains is going to be x minus 3. When it's the factored form is more convenient for when you're doing this increasing, decreasing stuff. All right? Anyway, what are the critical numbers? I set f prime of x equal to 0, and it says 4x squared times x minus 3 equals 0. And I solve for x. I just get x equals 0, x equals 3. It's already factored for me. Next in the procedure we did last time, make a little chart. My chart is going to have the signs of f prime on each of these three regions. So I know f prime is 0 at 0 and also 0 at 3. That's what I just determined. And now we're going to plug in points in between those values, those points there, and figure out if it's positive or negative. So on the left side, I will choose, your favorite number less than 0. I'm going to choose minus 1. So I go f prime of minus 1. Plugging in, I will use the factored form, just because that's the easiest to plug into. without using my calculator. I don't really like plugging into that top equation. So it's 4 times 1 squared times 1 minus 3. And is that positive or negative? Remember, if you just have a bunch of stuff multiplied together, you can just check if each part is positive or negative. In this case, it's a positive, and then a positive, and then a negative. Yeah, question? Did I mess it up? Oh yeah, I'm plugging in -1. Thank you. It does matter. Well, no, I'm gonna get the same answer, but yeah, it should be -1. -1, -1, right? Anyway, the answer is still positive. This part is positive, and this part is negative, right? Great. I was just reading a post online. Somebody asked, like, one of these question and answer websites. It said, as a teacher, how can I maintain the respect, maintain authority in the classroom when my students are correcting me? I hope you still respect me. Sometimes I mess up the numbers. I'm not terribly good at doing the numbers. And if you don't respect me, I suppose that's all right too. That's kind of my own personal answer is I don't especially care if people respect me or not. I hope that I'm living a respectable life, but, you know, everybody's got their own opinions. All right, so negative right there. What about the next region between 0 and 3? I will choose my favorite number in that range, I guess, is 1. So I'm going to do, now, this is what I wrote before. Like so. Before I was so disrespectfully corrected. Oh, I appreciate it. All right, that one is also negative. And then the one on the far side of the 3, f prime, I will choose 4. And I get 4 times 4. These should be squared, right? Doesn't matter. And then 4 minus 3. This time they're all positive, 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 so it's positive over here. All right? So that's the chart for increasings and decreasings. All right? We're kind of halfway done, maybe 1/3 of the way done. I want to do that for increasing, decreasing, and then also do the same thing, but for concave up and concave down. That involves the second derivative, so go back to your first derivative here and take the derivative again. Now, I have 2 different formats for the derivative, but actually the first one is much easier to take the derivative again on. If you want to use the second one, you have to use the product rule, which I don't want to get into. So I'm going to use the first form of that right now. So now I'm going to do concave up / down. And I will grab this again. So starting with the first derivative, I'm going to take the derivative again. So it is f double prime of x equals 12x squared minus 24x. All right. I'm still thinking about respect in the back of my mind. I have a friend who's Korean. He's from Korea. And he said to me once, I couldn't believe when I met you, you're a math professor. Because in Korea, professors are so very respectable. All right. I think he meant, English is not his first language. I think he meant, I don't present myself as a super formal. I took it as a compliment that I'm not, elitist or something. I appreciate that. Okay. So this is the second derivative. We now do the same business, but using this formula. So I am, again, going to factor it first, because this will make the subsequent steps easier. Here I can pull out 12 and x, and what remains will be x minus 2. And so when I set this equal to 0, my solutions are going to be 0 and 2. So f double prime equals 0, I get x equals 0, x equals 2. So I make that chart. All right, looks similar. It's not the same though. Remember before, my numbers were 0 and 3, so it is different. And again, I'm going to plug in points in between. So I'll start with -1 on the left side. F double prime of minus 1. Let me just put this. I usually put a little 0 here and a little 0 here. That's where the f double prime is 0. On the left side, f double prime minus 1 is 12 times minus 1 times minus 1 minus 2. This is positive, negative, and negative. So that's going to be positive over there on the left side. In the middle, I'll choose plus 1 again. F double prime of 1 is 12 times 1 times 1 minus 2. This is positive, positive, negative. So that's going to be negative in the middle. And on the right side, I'll choose 3. 12 times 3 times 3 minus 2. This is positive, positive, and positive. So positive over there. All right. Okay, we're mostly done. Start drawing a little graph here. And this is the one step at which I might use my calculator to find the y values. This is the pain sometimes. Sorry, this is supposed to say values. Plot the critical numbers and the inflection points. I will just remind us, our critical numbers in this case were x equals 0, x equals 3, right? And our inflection, I didn't say this before, but these are inflection points right here. These are 0 and 2 are where the concavity switches from being concave up to concave down. That's called an inflection point. So the inflection points here are x equals 0, x equals 2. All right? How do we find the y values? Anybody say? How do you find the y values in this problem? Yeah? Yes, we plug into the original function. You got to keep it straight between the function and its derivative and the second derivative. To find the y values, we plug into f of x, not f prime, not f double prime, f of x, which I will refresh our memory, is x to the 4 minus 4x cubed. And this, like I said, this is the step which is sometimes annoying to do without a calculator. You have to actually plug the numbers in and get the y value. So f of 0, this is the y value when x equals 0. That's easy enough. That's just 0 to the 4 minus 4 times 0 cubed, which is 0. F of 3, that's my next critical number. This is a bit of a pain. 3 to the 4 minus 4 times 3 to the 3. This I did ahead of time. This is negative 27. Not so hard to do by hand, but I'll just tell you what it is. And then when I plug in f of 2, this is an inflection point. It's going to be, 2 to the 4 minus 4 times 2 to the 3. And this is negative 16. All right, so I'm going to plot those points. I got 0 twice, you can't draw it twice. I'm going to plot those points on my graph. I think I'll start on the next page here. Hope you got those numbers. It's 0 is 0. So f of 0 is 0. Actually, these are all pretty much, the action in this graph is going to be down there. Anyway, f of 0 equals 0. This is a critical number. Maybe just to remind myself that this is a critical number, I'm going to put a little sort of a horizontal line through that. That means that when the curve, I don't know if you can see that, when the curve eventually crosses through this point, it will be moving with the horizontal tangent. It'll be going flat through that point. All right. Then we also had the inflection point at 2, x equals 2, y equals negative 16. So I'm going to try to put that here, 2, negative 16. There's an inflection point right there. And then I also had 3 and negative 27. So I'll put that here, 3, negative 27. And this also was a critical number, so I'm also going to put a little horizontal bitty bit right there. When the curve goes through that point, it's going to be horizontal. Not so for this one, though, right? This was not a critical number, so when the curve goes through this point, it's just going to go through it at some angle, right? Not horizontally. Okay? And now, the rest of your job is connect the dots, draw in the curves, using the correct shapes given by the increasing, decreasing, and the up-down thing. So what you need to do is sort of summarize the two charts that we made before. I will copy them down again. This was the increasing, decreasing one. It said 0 to 3, and it was minus, minus, plus. And then we had the concave up-down one, and that one was 0 to 2, and it was plus, minus, plus. That's what we did before. And when I redrew it here, there's a very, very small subtlety. I hope you notice, I try to actually line them up. Like the 0 and the 0 are lined up here. And the 2 and the 3 are not lined up. The 2 is to the left of the 3. Because what I'm about to do is kind of look at both charts at once in the various regions on this picture. For example, to the left of the 0, it is decreasing and concave up, right? According to my two charts. To the left of the 0, and maybe I'll just sort of write that in over here. Decreasing, up, right? Between 0 and 2, that's between these next 2 points, it is decreasing and concave down. Decreasing, down. All right, between 2 and 3, according to these two charts, that's this area, it's decreasing and concave up. So this is decreasing, up. And then to the right of the 3, it's increasing and up. I'm just combining the information on my charts, my two charts for each of those regions. And once you figure those out, it will be clear what shape the curves have to be. And you can either think this through or sort of memorize the various shapes. The shapes go like so. Here's a little kind of a chart. This is what the shapes will always look like. Up, concave up and increasing. That means it's the smiley face, the smiley shape, but only the increasing portion, which looks like this. Concave up but decreasing is the other half of the smiley. The bad curve, like that, right? Increasing but concave down means that. It's going up, but it has the frowny shape. And decreasing concave down means it's going down with the frowning shape, which is that, all right? If you can remember this little chart, or just think it through every time. Anyway, those are the shapes of the curves that I'm about to draw. So to the left of the origin here, it should be decreasing concave up, which is that shape. So that's what I'm going to draw in here, like that, right? I used this shape right here, a little wobbly up there. And you will notice I came into this curve horizontally. That's because I know that's a critical number. When you go to that curve, it should be going horizontal. All right, how do I connect these two dots? It should be decreasing and concave down, which has this shape. And so between those next two dots, it should do that. Something like this, right? And remember, since that was a critical number, it should be flat when it goes through this point. It should not be flat when it goes through this point. And it's not. I didn't draw it as flat, all right? Between these two dots here, it is decreasing and concave up. That's this shape. So put that shape in, like so, coming to a flat tangent line at that last point there. And then finally, to the right, it's increasing and concave up. That's this shape, smiley shape going up, like that. And this is what the graph looks like. All right. That's it. I would say these kinds of problems, like individual steps, are not really hard, but it'll still take me 19 minutes to do that, right? Now, once you know what you're doing, you can do it quite a bit faster, although not a whole lot faster. It'll take you a few minutes to do a problem like this. All right. Any questions about that? I just want to do some more examples. If these rates continue, I could do 2 more before the end of the hour. All right, let's see. I got another one which is very similar, also a polynomial, but we're going to do some that are not polynomials, but yeah, let's do another one. You might want to remember that little chart of shapes there. Okay, how about, here's another example. F of x equals x cubed minus 6x squared minus 135x. That 135 is going to be a little bit of a pain, but it's fine. All right, same business. What should we start with? The increasing, decreasing. So I am going to find the critical numbers. This involves the derivative, right? So I do f prime of x is going to be 3x squared minus 12x minus 135. Can we factor that? As you know, if you can't factor, you sometimes have to use the quadratic formula. There are some on the homework, which you may have seen, that have just like weird decimals in them. You have to use the quadratic formula. Although I think you can factor this one. Any suggestions? 3. Yeah, I don't like it when there's a coefficient on the x squared. So let's just factor that all the way out to begin with. Factor out the 3, because I think everything there is divisible by 3. X squared minus 4x minus 135 divided by 3, I believe, is 45. Isn't that right? I think 45 times 3 is 135, right? Anybody see how to factor that? I'm going to do one of these guys, right? Has to multiply to 45 and add up to -4, yeah? Yes, 9 and 5 is what you want. And I believe it's -9 and +5, right? That way you get -4 in the middle. And the product is -45. Great. Okay, so this means my critical numbers, I set that equal to 0. It's already factored. I get 9 and -5 for my critical numbers, right? Are x equal 9, x equal -5. These are the 2 points where the derivative is 0. Ordinarily, we also need to check when the derivative does not exist, but that's not an issue in this problem because there's no denominators or anything. So we don't really have to worry about that in this case. These are my 2 critical numbers. I make the chart, -5 and 9, right? And I'm going to plug in values like we usually do. On the left side, I would use -6, I suppose, plugging into this thing in the box. So f prime of -6 is 3, -6 minus 9, -6 plus 5. This is plus, minus, and minus. So that all is positive. Positive times a negative times negative. All right? In between, in the middle, I choose 0. F prime of 0 is 3, 0 minus 9, 0 plus 5. This is positive, negative, and positive, so that's a negative in the middle. And then f prime, on the right side, I'll choose 10. A nice friendly number. 10 minus 9, 10 plus 5. This is positive, positive, positive. So positive on the far right. All right, this is our increasing, decreasing charts. Doing okay so far? I hope so. Now we do that same business, but using the second derivative. So this is for the concave up versus down chart. I'm going to start with this form of the first derivative. This one here, because that's more convenient to take the derivative of than the factored version. So f double prime of x is derivative again. I guess it's going to be 6x minus 12. No 135, I like that. I suppose you could factor this if you want to. This is pretty simple anyway, but it's 6 times x minus 2. And so when I set that equal to 0 and solve, I'm going to get x equals 2, right? So f double prime equals 0 gives me x equals 2. This is my only point to put on the chart for the concavity. And we plug in, as always. Plug in, say, to the left of 2, I'll use 0. F double prime of 0 is 6 times 0 minus 12. This is negative. And then f double prime, let's say 3 on the right side, is 6 times 3 minus 12. 6 times 3 is 18, so that's positive. All right, I got my two charts all worked out. So it's concave down to the left of 2, concave up to the right. Great. What next? You remember what we did before? Yeah, get the y values for the critical numbers and also the inflection point. So that's the inflection point. There's only one inflection point, 2. All right, so my important numbers are going to be, just to summarize, the crits were -5 and 9, right? And the infl is 2, right? And we need the y values for all of these. So I'm going to go f of -5, f of 9, f of 2. Using the original function, so for -5 it would be -5 cubed minus 6 times -5 squared minus 135 times -5. This I did in my calculator, obviously, and I got 400. There are going to be some big numbers here. When I plugged in f of 9, I got, you ready for this? -972. And when I plugged in f of 2, I got -286. So those are the 3 y values that we're going to care about. All right. So I'm going to start by plotting those points. -5 and 400. I'll just put this here and maybe here. -5 and 400. That's a critical number. I'll put my little horizontal line through there. Then I got 2 and -286. 2 and -286. It's here. And then finally 9 and -972 is here. That's another critical number. All right, and now I just got to recall my two charts. I'm going to draw them again just so you can see them together. This was the F prime chart, the increasing decreasing, went -5 and 9, and it was plus minus plus. And then the second derivative chart went just with a 2 in the middle, and it was minus on the left, plus on the right. So like I did before, I'm going to try to sort of combine these two charts or superimpose them, something like that. To the left of the -5, I see increasing and concave down. So this is increasing, concave down. Between the -5 and 2, I see decreasing and concave down. Decreasing down. Between 2 and 9, I see decreasing and up. And to the right of 9, I see increasing and up. And then you just draw in the old shapes. Let's see what we got. Increasing and down means it's going up but has the frowny shape, so it's like that. Decreasing and down means it's going down with the frowny shape, so it's like this. And then next is decreasing and up. That means the smiley shape, but it's going down, so it's like that. And increasing and up means the smiley shape and going up, so it's like that. Nice looking. Is that what you expected it to look like? It was a cubic formula, a cubic equation, which generally you should expect to look like this. So I feel pretty good about that. Any thoughts about that one? Questions? It only took me 10 minutes to do that one. All right. Great. I got one for you to try. We got enough time, I think, for you all to try one. And so these two that we did were pretty similar to one another. I have a harder one that I want to do. I guess we'll do that next time. I want you all to try one. This is another polynomial, although this is a degree 4. 1/2 x to the 4 minus 4x squared plus 3. This one does have some weird numbers in the second derivative, if you encounter weird numbers. You're doing it right. Maybe. See if you can do it. Sketch the graph. You don't have to use a quadratic formula, but you do get slightly weird numbers. Feel free to talk to your friends. I'm gonna go over this in a couple more minutes. I'll give you a few more minutes. Couple minutes or so. Yeah, yeah. Is that? All right, let's talk about these. I don't know if you finished yet. It's fine if you didn't. I don't know if I can do it in 9 minutes, but we'll see what happens. Everybody did the derivative, right, at least? So it's 2x cubed minus 8x, and the plus 3 goes away. I'm going to factor like I usually do. Factor out 2x, and what remains is x squared minus 4. And that x squared minus 4 can factor as x plus 2 and x minus 2. So I get a total of 3 critical numbers this time. They are x equals 0, x equals minus 2, x equals plus 2, right? These are the 3 critical numbers. So I'm going to make that chart. Minus 2, 0, and 2 over here. And we plug in the, you're going to have to choose 4 numbers to plug in here. I saw pretty much everybody already did this part, so maybe I'll just skip the details. It should be a minus, a plus, a minus, a plus, like that. If you plug these values in properly. I hope you got that. This is for the increasings and decreasings. Then I do the, any questions about that? I think as I was going around, pretty much everybody came up with that. Now I do the second derivative. It is, take the derivative of 2x cubed, it is 6x squared minus 8, right? And this, you can't get too far by factoring, but you could factor 2 out, and then what remains is 3x squared minus 4. And this is where these annoying numbers come in. When I set that equal to 0, it says 3x squared minus 4 equals 0. I add the 4. 3x squared equals 4. I divide the 3. X squared equals 4/3. And then I take the square root. And I get x equals plus or minus square root 4/3. This is a annoying number. But, oh, I'm looking at my paper now, and I see that I messed that up somehow. I wrote square root of 2/3. Did anybody plug this into your calculator? What is that number? 1.6 something? I still had something over there. Did anybody? Nobody wanted to plug that into your calculator? What is the square root of 4/3? 1 point. All right, thank you. This is important because, I mean, it's at least slightly important because you're going to make that chart and you have to choose some number bigger and some number smaller. You have to have some idea of what that number actually is in order to choose the biggers and the smallers. So I go this number, negative 1.15, and then positive 1.15, or you could just write it as root 4/3. Although you have to know vaguely what the number is to choose your 3 plug-in values appropriately. So I'm going to choose f double prime of, say, to the far left, I'll use negative 2. Plugging in up here, 2 times 3 times minus 2 squared minus 4. This is 2 times 12 minus 4, which is positive, right? Then I will choose in the middle, 0. I can tell just by looking here, when I plug in 0, I'm going to get 2 times negative 4, which is negative. And then I'll plug in on the far side here, positive 2. It's going to be also positive over there. Did I do it right? I think I did it right. I hope those are the signs that we got. All right, I think we're ready now to find the y values, which I would definitely suggest you use your calculator for, and then try and draw the picture. So let's find the y values. My x values, I guess I have 5 total, right? These ones, the critical numbers, negative 2, 0, and 2. And then these ones, the positive and negative root of 4/3. So let's just go down the line here, I guess. F of, I did everything wrong on my paper. Sorry, maybe could I have some help from the folks out there? Anybody calculate these numbers? What did you get for f of negative 2? Negative 5? Everybody agrees? Sounds all right to me. Okay, and then f of positive 2 should have also been negative 5. You can tell, actually, the original function here, all the powers of x are even. That means if you plug a negative number or a positive number, you're going to get the same answer anyway, because these powers on x are both even. Any negative signs on x are going to get sort of washed away by the powers. There's also f of 0, which I can do even without my calculator, is just 3. And then the other two values, the root of 4/3. So f of minus root 4/3. What did you get for that? Somebody work this out. Yeah. Negative 1.44. Anybody agree with that? Yeah? Okay, great. Like I said, I messed it up on my paper, so. And this other one should get the same answer. Like I said, because negative versus positive values for x will give you the same answer for this particular function. All right. Let's see if we can do it. Maybe I'll just draw it right here. So f of 0 is 3, and that's a critical number. I'll put a little thing there. This is 3. F of 2 is negative 5. That's down here. This is 2. X equal 2, y equal negative 5. That is also a critical number. I'll put a little line there. F of negative 2 is also negative 5. Also a critical number. And then f of 4, square root of 4/3, which is something like 1.15, that would be, that would be around here, I guess. Root 4/3. That value is negative 1.44. So right here. And then I also get this one right here for the negative root of 4/3. All right. And then when I look at my charts to tell what shapes it should have, it's going to be one chart goes -2 to 0 to 2, and this one was decreasing, increasing, decreasing, increasing. And then the concavity chart was like this, whatever, this is like 1.15, negative 1.15. And this one went up, down, up, right? And so, to the leftmost part of this curve here is going to be decreasing and concave up. That means smiley shape, but going down. That's like this. Next region is still concave up, but increasing this time. That means smiley shape going up. The next region between negative 4/3 and 0 would be here. Increasing, but concave down. That's like so. The next region is decreasing, concave down, which looks like this. Frowny shape and going down. The next region is decreasing and concave up, going down but smiley. And the next region, the last region, increasing, concave up. Looks like, come on now, looks like that. There you go. I hope that's what you got, something like that. All right, we did it, perfect timing. We're going to do one more of these next time, a little bit harder. We'll also have our quiz as usual. See you then.